Yesterday when we talked about this trig stuff, we said, I kind of mistakenly said, okay, now we're going to do a section where we really put it into action. We're going to solve for angles, we're going to solve for sides and that kind of thing. Well, we didn't really get to that, but today we are going to get to that, all right? So that's what we're going to do today. So let's do this. This book wrote this a certain way. I hadn't seen it like this, but I kind of like this. They say that this is, they call them definition. I don't know if I would call it a definition, to tell you the truth, but this is what they do. And they say, what if you had this? So they have a big if in front of this. So if the sine of theta is equal to x, what I want to do is I want to solve for theta, a missing angle. All right? Everybody got that? So what I want to do is I want to do some algebra, kind of, and I want to solve for theta. So normally, what would you do if something's right next to what you're trying to solve for? We'd usually divide, wouldn't we? Right? So we'd go, but you can't divide by the sign. The sign's not a number. It's not a variable. You can't divide by it. But you can do something with the sign, right? And you can take the inverse of the sign. Let me show you, before I show you the notation here, let me give you a, let's go back in time a little bit. What if I had like this, 2 to the negative first? Did you guys do that in Algebra 1, negative exponents? Yeah. I don't think, we haven't done it this year, have we? Negative exponent?
We did it for a little, you showed us.
Did we? Okay. I just can't remember. What does that mean if I have something to the negative first? Yeah, it's 1 over, correct. It's 1 over 2. So good. So you're familiar with that then, right? What is 2 and 1? If I compared 2 to 1/2, they're what of each other? Inverses of each other, reciprocals of each other. You could use either word. It's perfectly fine, okay? So they're inverse. We're going to use the word inverse. Is that all right? They're inverses of each other. So what I want to do is I want to get rid of this sign. Okay, so I'm not going to divide by the sign because that doesn't really mean anything. The sign is just a word that indicates you're taking the ratio of the opposite side to the hypotenuse. Okay, that's the only thing that sign means. So I can't divide by it, but I can take the inverse of it. And this is the reason why I did this, because the notation for inverse is if you take something to the negative first power. Does that make sense? So here's what we're going to do. In order to get rid of the sign, we are going to take the inverse of the sign. Let me write that again. There we go. We're going to take the inverse sine of the sine theta. Now, you know what you did in algebra, right? Whenever you did something to one side, what? You always do it to the other side. So guess what we're going to do over here? We're going to take the inverse sine of what? Of the other side. What is it? Of x. Good. Okay? So what happens here? What happens when I take the inverse sine of the sine? What do you think they do? If I take the inverse of something, what's that? No? Let me just try to think. What if I had this? What if I had 3x equals 12? Okay, I want to take the inverse of 3, right? I could write 3 to the negative first, couldn't I? Or I could put divide by 3, right? So normally we just divide by 3, but you can't divide by a sign. So let's write it like this. So if I wrote 3 to the negative first, what happens to that 3 to the negative first and the 3 to the first? That's 3 to the 0 power, isn't it? Okay, so that's 3 to the 0 power, and what's anything to the 0 power? It's just a 1. So what happens to this 3 to the negative first and 3 to the first? What do they do to each other? Come on, say it. We say it all the time in algebra. They cancel out, right? They cancel each other out. So what does this inverse sign do to the sign? They cancel each other out. You got it. Everybody see that? So how do I get rid of a sign? Take the inverse sign. And how do we show inverse? We show it to the negative first power. Does that make sense? That's why I went back to show you this stuff. All right, because to the negative first power means we're taking the inverse of it. So how am I going to write this? I'm going to write it theta equals the inverse sine, and usually we put parentheses around this. This could be a number, all right? Could be a fraction, and this is the way we're going to write it. So this is what we're going to use to actually solve for an angle. All right, using trig, we're going to actually solve for a missing angle in a right triangle, and that's our method of doing this. All right, so I'm not going to explain as much on the next one. So what if you had the cosine of x, or theta, equals x? How would I get theta by itself? What's theta equal to? Just in your head now, you should be able to do that. How do I get rid of the cosine? Take the inverse of the cosine. Take the inverse of the cosine here. So how do I show inverse? I show it to the negative first power of x. You got it? So that's how I could solve for that. And let's do one more. Let's do tangent. So what do you think I'm going to do now? Tangent of what? Theta equals x. So if I want to get theta by itself, how do we get rid of the tangent? Take the inverse tangent. They'll cancel out. I'm left with theta. I got to do it to the other side as well. So I take the inverse tangent of the other side of x, and there you go. You don't have to really memorize these, just understand the process, okay? Just understand the procedure on how to get theta by itself, because that's the kind of stuff that we're going to be doing. All right, let's go to an example now. Hopefully this stuff's going to make sense when we actually do the examples. So here's example 1. They kind of word the problem a little weird, a little different, but I'll word it the way they do, because if you see it in the book, you'll need to know what they're asking. It says, find the acute angle. Find the acute angle whose sine is 3/10. Like, what in the world's going on there? I'm trying to find an angle, right? Trying to find a missing angle. Okay, one of the acute angles. So I'm not finding the 90, right? And again, we're all dealing with right triangles here. So you know you're going to have a right angle. Agreed? Okay. Where are you going? Bathroom. Going to the bathroom and you're leaving early? All right. All right, so here's what we're going to do. It says find the angle. If it's an unknown angle, what letter do we use a lot of the times? We just used it earlier. An unknown angle. No, that wasn't the angle. What was the angle? Theta is the angle, right? So we're going to call one of these angles theta. So let's call this theta right there. Is that all right? It says find the acute angle. We'll call it theta. Find theta, whose sine is 3/10. So if I take the sine of this angle, I'm going to get 3/10. So how do I know what side is what? So what is the sine of an angle? The sine of an angle is what over what? Opposite over hypotenuse. So if this is the angle we're dealing with right here, what's the opposite? Which side is the opposite? This side right here. Okay, so what's the value of it? That's 3. Over the what? Hypotenuse. So what's the hypotenuse going to be? It's going to be 10. Okay? And so what we want to do is we want to find what that angle is. Up until today, you would have never been able to find that angle. You'd be able to find that side, wouldn't you? Because you could do Pythagorean theorem to find the side. But then you got 2 unknown angles, you'd be stuck. There's no way you could have figured out what either one of those angles were. But now we're able to do it since we know just a little bit of trig. So here's how we're going to set this up. Remember how we set this up? We said the sine of the angle is equal to what? 3/10. So this is my x. That 3/10 is my x in what we did earlier. You see that? See the sine of theta is equal to x. So what we want to do is find what? We want to find theta. So how do we find theta right now? Do the inverse sine of both sides. That's right. So we take theta, take the inverse sine of this side. You know it's going to cancel out, right? So you take the inverse sine of this side. So you go sine to the negative first of 3/10. And that's what theta is equal to. But that's kind of ugly. We don't want to leave it like that. What do you think we're going to do to actually get a degree angle for this? Put in a calculator. Very good. So let's bring the calculator out. And let's change it to degrees. Now I finally remember. Took me a while to remember to do that, but now we're ready to go. So how in the world do I do this? This sign to the negative first. Well, if you look at your calculator, I think no matter what calculator you have, you should see this. So if I look at the sign button, see the sign button right there in white, just behind it on the back, not the back of the calculator, but the I don't know, what would you call that? Like the surface of the calculator? I don't know. But right there, you see it? It says sign to the negative first. It's kind of small, but that's what it says. If you look at your calculator, you'll probably see it. All right, so how do I get to that yellow one? Hit second function, sign. Look what it does. It puts sign to the negative first, doesn't it? Just like we wrote it. And then what are you going to put after that? 3 divided by 10. I like to close off the parentheses, and then we hit enter, and that's my angle right there. 17 point, let's just round it to 1 degree. I think that's what they do. Yep. Let's just round it to 1 degree, or not 1 degree, but to the 10th of a degree. So what would that be? That 5 rounds that up, so 17.5. So that angle right there would be 17.5 degrees. Everybody got me on that? So there you go. That's the first time. That's the first time that you've had a right triangle. You didn't know either one of those acute angles, and you're actually able to find it. That's kind of interesting. All right? So now you can do something that you were never able to do before. I think that's kind of cool, don't you? Yep, just gives you one more weapon to use in solving for missing stuff, right? And that's kind of what math basically boils down to, isn't it? Just solving for missing stuff, all right? And that's what we did. Now, you could solve this side right here if you wanted to. You could also find this angle right here. How could you find this angle? We'll call it alpha. How could you find that little angle right there? You got it, 90 minus 17.5, okay? Or you could have done this. Watch this. What is 90 minus 17.5? 72.5? Is that right? Somebody, you got a calculator? 72.5? Yeah. I think that's it. All right. Watch. Here's another way to do it. You could use this alpha instead of this theta. All right, so let's do that. Now, I'm not going to use the sign this time, am I? All right, so let's say you didn't know this was 72.5. All right, now we do know it, but let's say we didn't know it. And we wanted to use this angle up here. And I still knew this was 3, and I still knew this was 10. All right, so what am I going to do? How am I going to set this up? Well, what is this 3 to this angle alpha up here? That's adjacent. What is the 10? It's hypotenuse. Which trig function, or trig ratio, they use that word, uses adjacent and hypotenuse? The cosine. So we're going to take the cosine of the angle, which is alpha this time, all right, is equal to the adjacent over the hypotenuse. What is adjacent? 3 over 10. All right, so you're still using 3 over 10, but this time you're going to do the cosine. So now you should be able to do this without putting that, well, we did it here too. So you could kind of do this in your head, all right? So alpha is equal to, take the inverse cosine of both sides, of 3 over 10. All right, and now you put that in your calculator. So second function cosine, so there's your inverse cosine, and of 3 over 10, so 3 divided by 10. And then you get, check it out, 72.5, just like we said it should be. It's kind of cool, isn't it? Now, it was probably a little easier just taking this away from 90, but it's just cool that you could see you can do your trig both ways. And again, if you wanted to, you could solve for x. They're not asking you to right now. They will in a minute, less than a minute, because we're going to do an example where we're going to have to find everything on the triangle, not just the one angle. All right? So let's do example 2. This one says solve the triangle. It's kind of weird. It says solve triangle ABC. What does that mean, to solve the triangle? Solve for what? Yeah, solve for all the sides and angles, anything that's missing. Okay, so anything that's missing, that's what we want to find. So they're not going to say necessarily solve for angle A, solve for angle B. They're just going to say solve the triangle. All right. So let me give you some information that they give you. They say this is 4, this is 7, this is side C, this is angle B, this is angle C, and this is angle A. All right? And that is all they give you. And that's all they give you on the other one, right? That 3/10 thing. And that's all they give you here. So let's see. What do you want to solve for first? You can solve for A, or angle A. You can solve for angle B. You can solve for side C. Let's do side C first. Is that all right? So let's solve for C. So what am I going to use to solve for C? Do I have to use any trig? Nope. What am I going to do? What method am I going to use? Tell me that. Come on, somebody say it. I want to know you're awake. Pythagorean theorem. Okay? Did that come to you? All right, say it. I need some feedback from you guys. All right, so Pythagorean theorem. So what do we got? We got c squared equals 4 squared plus 7 squared. So that's what? 16 plus 49. And then c is equal to just the square root. I've already done it, so you can just put that in your calculator. You get approximately 8.1. We're just going to round everything to one decimal place. Is that all right? So it's just 8.1. It's approximately. I didn't put approximately, but that's okay. All right, that was easy enough. Didn't have to know any trig to do that. You could have done that back in geometry, right? Now, this stuff right here, let's find A first. We'll kind of go in alphabetical order. So let's find angle A. This is angle A. You don't have to call it theta. We'll call it A since you got an A right there. I think the book uses alpha and beta. Beta is a weird letter. It's like a weird looking B. I think when I would write a beta, I would write it kind of like that and leave this hanging at the bottom just to make it look a little different than a regular old B. But I'm not going to use beta. Again, that's a Greek letter of the alphabet. Let's use A. So how do I know which trig function? I got 3 to pick from, right? I got sine, cosine, and tangent. How do I know which one? Well, you look at the sides that we're given. Now, we do know this one is 8.1. But what did I say yesterday? We don't really, I think I said it. Was it this class or my other class? It might have been another class. I'm teaching trig in 3 different classes, so I can't remember what I say in what because I'm kind of teaching the same thing. But see, this is an approximation, isn't it? All right, so I would rather not use the approximation. All right, I would rather use the numbers they give me originally. So let's stick with the 4 and 7. You okay with that? So let's not use a hypotenuse. So what do I got? I got opposite and I got adjacent. Which trig function uses opposite and adjacent? The tangent. So I take the tangent of A, because I don't know what the angle is equal to opposite, which is 4 over 7. All right, see what I'm doing now? And now you can get A by itself. Take the inverse tangent of both sides. I just don't show it on the left side. Don't really need to. And now you just plug that into a calculator. Again, just for the sake of time, I've already done it. So it's 29.7 degrees. So that's angle A. All right, that's 29.7. So you could find angle B just by taking that away from 90. But since we're trying to learn the trig, let's do a little trig to find it and see what we get. It's 60.3 right there when you just take it away from 90. So 90 minus 29.7 is 60.3. So that would be the easiest way to do it, but let's do it using trig. So that's because that's what we're trying to learn here. So let's find angle B. So here's this angle right there. Let's find that. Well, again, I got opposite and I got adjacent, don't I? So I'm going to use the tangent. But this time, the tangent of angle B, which one's opposite to angle B? It's 7 this time. And then the adjacent is 4. So it's a little different. And so let's see. Get B by itself. Take the inverse tangent of 7 over 4. Plug that into a calculator. And angle B is going to be 60.3. It's not exactly 60.3. It's an approximation, right? We had to round. I don't know. We might have to round. But I just rounded it to the first decimal place, and that's what you get. It's pretty easy stuff, isn't it? It's not that hard. It's really no harder than your basic algebra, I think. I don't know. Maybe just because I've been doing it a while. It's kind of new for you. It's not brand new for you, but it is a little bit new. All right. Well, that's one page of my notes done. Ready to do some more? Yeah, that was pretty easy stuff. The next part, man, this is super important what we're going to do next, because we're going to do some things later on that uses what we're going to do right now. So what we're going to do is talk about some special angles. I think we mentioned it yesterday. Remember I said, remember the square root of 3 over 2? And then remember a half. And then I said, remember square root of 2 over 2. Okay, those are important values. Okay, really important values because they're parts of special triangles. And you might remember from geometry doing special triangles. Do you remember doing a 45-45? Have we done that this year at all? Okay, I don't think so. So this will be a little reminder for you. It may come back to you. I don't really expect you to remember everything from this, but at least I think you should look back on this and say, oh yeah, I remember doing it, okay? If that's all you remember, that's good enough. All right, so what I'm going to do is this. I do it a little different than what the book does as an explanation because of what we're going to do later. We're going to do a thing called the unit circle later, and the hypotenuse of this triangle kind of corresponds to the radius of a unit circle. Unit meaning 1, so I'm going to make that hypotenuse equal to 1. Is that all right? I just arbitrarily out of the blue just made it 1. But what I want to do is I want to find the other two values. I want to find this value, this side and this side. Now, if this is a 45-45 90 triangle, what do I know about both of these sides right here? Remember that from geometry? If these two angles are equal, what's true about these two sides? They're equal to each other as well, okay? So if I can find one side, then the other side is going to be exactly the same. So I'm just call it x, and I'll call this one x. No reason to call it a different letter because they're exactly the same, right? So if I call one x, I'll call the other one x. Everybody getting this? Everybody writing it down? See a couple people nodding off, 2 or 3 of you. Let's wake up. Let's write this down, okay? So what do I do to solve for x? I don't have to do any trig. What can I do to solve for x here? I guess I could do trig, but I'm not going to. I got an x and an x and a 1. What do you think? We've already done it once. Yeah, Pythagorean theorem. X squared plus x squared equals what? 1 squared. Agreed? Yeah. What's 1x squared plus 1x squared? That's 2x squared equals 1 squared, which is just a 1. Divide both sides by 2. X squared is equal to 1/2. Get rid of the squared. What do? Square root both sides, right? Well, what's the square root of 1 over 2? Well, it's 1 over the square root of 2. Agreed? Square root of 1 over square root of 2. Square root of 1 is just a 1. Don't want to leave it like this because we got a square root on the bottom. We rationalize the denominator. Okay, we've done that before. Top and bottom by the square root of 2. So now we finally got what x is equal to. What is it? Square root of 2 over 2. Remember we mentioned that number yesterday? I said it's one of those important numbers you got to remember. Okay, and we're going to do it some more. Okay, we're going to do a whole lot more. Okay, the square root of 2 over 2. That's a really important number. So what's the value of this? It's the square root of 2 over 2. What's the value of this side right here? Do I have to do any math anymore? No, it's the same thing. So this is also the square root of 2 over 2. So check this out now. Let me see if I want to do this. Yes, I do. Okay, so what we're going to do is find the sine without using a calculator. Okay, without using a calculator, we're going to find the sine of 45 degrees. Now I could put it in here. All right, put in 45 or put in sine of 45 and get a number. But I want to do it this way. So how do I find the sine of 45? Well, let's use that 45. It doesn't matter which one you use. Let's use this one. So what is the sine? The sine is opposite over what? Hypotenuse. So what's the opposite side? This one. So it's the square root of 2 over 2, correct? Over the hypotenuse, which is over 1. So what does that equal? Just the square root of 2 over 2. So knowing that the sine of 45 is equal to the square root of 2 over 2 is really important. And we're going to use it quite a bit later on. All right? I should be able to stop you in the hallway, tap you on the shoulder, and you're like, yo, Mr. Hammer, what's up? I'm like, look, you got to tell me, what's the sine of 45 degrees? And you'll say, well, that's easy. That's what? Square root of 2 over 2. Probably won't do that, but if I did, you need to be ready. Okay, good. All right, so that's how you do that. What about the cosine? of 45? This is kind of interesting. What's the cosine of 45? It's the adjacent over the hypotenuse. So it's the square root of 2 over 2. You could put over 1, but do we need to do that now? No, I did it once. Don't need to do it again. So that's the cosine of 45. So there's the sine of 45. There's the cosine of 45. I was just watching a video because I'm going to show it to my next class about trig, and the guy makes a point that I completely agree with. He's like, you don't need to memorize everything in math. A lot of times you should just be able to figure it out. Okay, so this sine of 45 is something you should be able to figure out. But, and I agree with him, memorizing too much is hard. But this is a number, square root of 2 over 2. That's a number that you really should have memorized. Don't just sit there and memorize it. You see where it comes from. You could always figure it out. What are we missing now? The tangent of 45. So let's do that. What's the tangent of 45? It's opposite over adjacent. Watch how easy this is. What's the opposite of that 45? Square root of 2 over 2. Over the adjacent. What's the adjacent to this 45 degree angle? Square root of 2 over 2. What is that? That's equal to 1. So what's the tangent of 45? Let's write it right here so it's nice and neat. The tangent of 45 is just 1. You could plug those into a calculator and see what you get. Some of your calculators will give it to you like this, square root of 2 over 2. Some of them will put it as a decimal. All right. I'm just not going to take the time to do that because I want to get as much done today as I can. Does that make sense? These numbers are super important. I think it's important to memorize these right here. These are special angles, special triangles. There's ones that pop up a lot. You should just be able to look at it and say, oh, the tangent of 45, that's 1. Cosine of 45, that's square root of 2 over 2. Sine of 45 is square root of 2 over 2. It's easy, right? Okay. Well, I don't know how easy it is, but it's not that bad. Do you remember the other special triangle? We had a 45, 45, 90. What was the other one? 30, 60, 90. Good. See, now your geometry is coming back. Aren't you glad you learned it? No? Of course you are. All right, so we have a 30, 60, 90 triangle. Let me draw one of those. Now, there was 2 things to learn about that. Oh, I could have shown you another thing too. Let me go back to that real quick. I'm probably wasting time doing this, but I'm going to do it anyway. No, just turn it in tomorrow. All right, let's go back to this. Do you remember? Let's do this in different colors. There's too much white on there. Let's add some splash of color. Do you remember this? That the hypotenuse on a 45, 45, 90 triangle, we learned something, that the hypotenuse was equal to, I don't know, do you remember this? The square root of 2 times one of the legs. Remember that? Yeah. At least it's popping back in your memory now, right? So instead of going through all this mess with this Pythagorean theorem and all that, you could have just realized that the hypotenuse was equal to the square root of 2 times one of the legs. That's what we're going to do on the 30, 60, 90. So how would I do that? Well, the hypotenuse was 1 equals the square root of 2 times one of the legs. What did I call those legs? Just x. Divide both sides by square root of 2. Rationalize the denominator. So what's x equal to? Square root of 2 over 2. You see that? So that works as well. I think I probably did this right here in geometry to show you that this is true. All right? So I did it again. All right. Let's do this one. There's a couple things we need to remember about a 30, 60, 90. You may or may not remember, and that's fine. I don't blame you. Let's say this is 30, and this is 60, and this is 90. This is my hypotenuse, correct? This is my short leg. Do you remember that? And this is the long leg. And we had 2 little things you were supposed to remember. The hypotenuse is equal to 2 times the short leg. Good. Because they both relate to the short leg. The hypotenuse, there's a relationship between the short leg, and then the long leg, there's a relationship between the short leg. So what is the long? Do you remember that number? Probably not, but that's okay. It's the square root of 3 times the short leg. Because the square root of 3 is just a little bit smaller than the square root of 4, isn't it? And the square root of 4 is a 2, so the square root of 3 is just a little bit shorter. So the long leg is just a little bit shorter than the hypotenuse. Okay? Do you remember that? Good. That makes the teacher feel good. All right, so what we're going to do is this. What did we decided we were going to make one of the sides equal to something right at the beginning. We made the hypotenuse 1. We're going to do the same thing with this one, okay? So what do you think I'm going to do now? Make the hypotenuse equal to a 1. So now let's use this stuff right here. So if the hypotenuse is twice as big, if this is twice as big as the short leg, let's put that number in. The hypotenuse is 1 equal 2 times, we'll call that y, we'll call this x. Okay? So the hypotenuse is 2 times the short leg, or 2 times what? Y. Divide both sides by 2, what's y equal to? It's a half. All right? So y is 1/2. What's the longer leg? Well, the longer leg is the square root of 3 times the shorter leg. All right? So that means the long leg is x is equal to the square root of 3 times the short leg. What did we say the short leg was? A half. What's a better way to write that, though? Square root of 3 times 1, which is the square root of 3, over 2, and there you go. So these are your other two numbers. Remember yesterday I told you that those numbers were important to remember as well. So the square root of 2 over 2 is important to remember, a half is important, and the square root of 3 over 2 is important. All right? Because we're using that with a 30, 60, 90 triangle. Still with me? Good. I find this stuff fascinating. Do you? So let's do this. Let's find the sine, cosine, and tangent of 30 without using a calculator, and find the sine, cosine, and tangent of what? 60. All right, so let's do that. Let's do the sine of 30. Yeah, just put it under here. Cosine of 30, tangent of 30. Now, we haven't really done any trig with this yet. It was all just geometry, okay? So let's now do this trig, the sine of 30. Oh, by the way, what did we say that was? Square root of 3 over 2, okay? Everybody good? So let's do the sine of 30. Sine is what over what? Opposite over hypotenuse, so it's 1/2 over 1, which is just a half. What's the cosine? Cosine is adjacent over hypotenuse. So it's just square root of 3 over 2 over 1, which just ends up being square root of 3 over 2. Agreed? And what's the tangent of 30? The tangent is the opposite over the adjacent. We might have to write that out. So 1/2 over square root of 3 over 2, which is 1/2 times the reciprocal of that, which is 2 over the square root of 3. Everybody's with me, right? 2's cancel out. What do I got? I got 1 over square root of 3. Don't want to write it like that. Can you do this in your head at this point? What's that going to be? You got it. Square root of 3 over 3. So that's what the tangent of 30 is. All right? Without even using a calculator, okay, we figured it out. Isn't that cool? Now, you can't do that with every angle. If that was like a 37 degree, is that a special angle? No. So I couldn't find the sine, cosine, tangent of 37 degrees without using a calculator. I'd have to use a calculator, okay? But with these special ones, with 30, with 60, with 40, with 45, okay, you should be able to tell me what the sine, cosine, and tangent is of all three of those angles. You with me? Kind of memorize it, but you want to think about it. I'm going to show you a better way in another lesson or two when we do the unit circle to kind of remember. But just knowing these numbers, knowing, even square root of 3 over 3, all right, you don't see that quite as much. But square root of 3 over 2, you see a lot. A half, you see a lot. Square root of 2 over 2, you see a lot. Okay? Everybody good? Now, what do we have to do? Do the 60, right. So let's do the sine of 60, the cosine of 60, and the tangent of 60. Now, we've talked about this the other day. You could, instead of going back to the triangle, you could just go back to this. Remember, the sine of 60 is going to be the same thing as the cosine of 30. All right? So let's write it in there. So what should it be? Square root of 3 over 2. Let's see if it actually is. Let's actually look at the opposite and all that kind of stuff. So what is the sine of 60? Opposite over what? Hypotenuse. Square root of 3 over 2 over 1. Bam. It is. It works out perfect, doesn't it? What about the cosine of 60? Should be the same thing as what? Sine of 30. So that should be a half. Let's see if it is. Cosine is adjacent over hypotenuse. Yep, it's a half. Good deal. Everybody good? Remember what this was? Before we change it to that, it was 1 over square root of 3. So what's the tangent of 60 then? It's the reciprocal of this one. So you could just write what? Square root of 3. So there's little shortcuts to figure this stuff out. All that without ever touching the calculator. It's pretty cool, huh? You're like, yeah, sure it is. It is. It is. I think it is. What's that? Is that sarcasm or are you truthful?
I really find it fascinating.
I do too. I think it's kind of neat how it all works out. So there has to be a designer to this. Did this just happen in a big bang? Did somebody make all this stuff up? No, somebody discovered it. Nobody made it up. They discovered it. And who was the creator? God was the creator, okay? I'm totally convinced of that. All right, so example 3. It says solve each triangle. All right, so again, what are we doing? We're finding all the missing stuff. All right, that's basically what we're doing. There's an A and a B to this. Let's do A. Now, these are special triangles now, okay? I'm trying to make them. It's a little too long, I think. Does that look about the same? Pretty close. Close enough, right? I agree. All right, so this is 45 down here. This is angle C. This is 5. This is angle A. This is angle B. And if this is angle A, what side will I call this? Side A. If this is angle B, what am I going to call this side? Side B. Just a lot easier than saying AC. Wouldn't you agree? Yeah, makes more sense. All right, so we got to solve for all the missing stuff. Well, the angle A is super easy. Super, super easy. What's angle A equal to? 45, exactly. All right, because 90 minus 45 is 45. All right, let's see. Let's find side A. Find side A. Now, here's where what we just did really helps. Okay, you don't necessarily have to do the sine and cosine to figure this out. All right, everybody watching? All right, you guys got something going on? Let's look up here. So let's solve for this. Remember, the hypotenuse is 5. All right, so what's the leg going to be? Remember when it was 1, what was the side? Square root of 2 over 2. Now it's 5, so what do you think this is going to be? It's not 1 times the square root of 2 over 2, it's 5 times the square root of 2 over 2. And there you go. See, knowing some of the early stuff makes this so much easier. I could have done Pythagorean theorem, couldn't I? I could have, A and B are the same thing, right? I could have called them both A if I wanted to, done Pythagorean theorem, do a whole bunch of work, and eventually I'd come out to this. But if you remember that basically what you're doing is this. You're taking 5 divided by the square root of 2, right? And then you rationalize the top and the bottom, and you're going to get to that. But you could also look at it as just remembering that that was the square root of 2 over 2 when this was 1. But this is 5 times bigger, so this is going to be what? 5 times bigger. You see that? All right, so that's kind of nice, showing you little shortcuts here. And then B is super easy. What's B going to be? Same exact thing. It's a 45, 45. So that's also 5 squared root of 2 over 2. Okay? They don't ask for the sine, cosine, and tangent of these, but they could. All right? What's the, well, yeah, we don't even have to do that because we've already done it. Let's do part B. So that was a 45, 45. Guess what this is going to be? 30, 60, 90. Very good. See, isn't it fun to play along? So, yeah, sure it is. All right, there we go. This is 30 degrees right here. All right, they make that G and F and E. This little side is 8. This is little e, and this one's little g because it's opposite, okay? All right, now let's go through it. 30, 60, 90. So angle E I could find right away. What is that? 60 degrees. Come on, marker, help me out here. Let's keep pushing this stupid button on here. So that would be 60 degrees, right? Because 90 minus 30 is 60. All right, what about, let's do the short side, they already give it to you. So that makes it easy. When they give you the short side, that everything falls together. All right, so let's do the hypotenuse first. So let's solve for G. So I know the short side, so what's the hypotenuse? It's twice as big as the short side, right? So what is it? It's just 8 times 2, which is 16. There you go. Easy. E is, it might be, some people might say it's even easier because I had to know what 8 times 2 was. Not that hard, but I still had to know that. But on this one, to find E, what do? That's it. I multiply by square root of 3. So all I got to do is write down 8 square root of 3, and then that's it. That's my answer. So that's G, and that's E. Look how easy that is. Oh, I knew I wouldn't have time. Yeah, we only got 5 minutes left. I'm not even going to try to squeeze the rest of it in. There's no way I can. But I've got like 1, 2, 3, 4, 3 examples to do. There's no way I can do that in 5 minutes. I tried my best, though. Went as fast as I could with still explaining everything. So tomorrow, what's tomorrow? Wednesday? So tomorrow, Wednesday, I will finish. I will finish lecturing 10.2. All right. Your assignment, if you want to get started on it, you might not be able to do. Actually, tell you the truth, the ones that I assigned, I think you can do every single one of them because, I think you can. I do, because the rest of them are kind of word problems a little bit with a picture and stuff like that. And I don't think I assigned any of those to this. So let's forget that and let's give you some homework. Let's put it in red so it stands out. How's that sound? All right, so here's your homework. It's section 10.2. Because the stuff I didn't get to, I didn't assign anyway. So it worked out perfect, didn't it? And you're doing 1 to 24. Sounds like a lot. I don't usually give you in the 20s. But some of these are really super easy. Some of them you just punch into a calculator. Not all of them, but some of them, okay? So 24 sounds like a lot, but really it's not that. It's not as much as some other lessons if I gave you 24 problems to do, okay? So there's your homework right there. And then so tomorrow we'll go over both of them. Then we'll decide tomorrow if we have enough time to review for the quiz or not. And then, but I would say right now we're still on track to take the quiz on Thursday. All right. If something disastrous happens tomorrow, hopefully not. But if it doesn't, Hunter's praying for it. But yeah, I think we're still good for being on track. All right. Everybody good? All right. Well, thanks for staying awake, most of you. And thanks for listening. And tell your classmates, if you talk to them or if you text them or whatever you guys do nowadays, tell them to watch the video because they're going to have to know this stuff. Everybody good? What's that? Send a link to them? Okay, good.